So the total expenditure on good 1 would be 120, right? Because you may divide $300 by 5. You make $300 as 5 shares, and you give 2 shares go to good 1, and 3 shares go to good 2, right? So it would be 120 versus 180. Get it? The power is the proportion of expenditure. Is that clear? Right? So Q1 star would be 120 over 5, so it's 24. And Q2 star would be 180 divided by 2, it will be 90. Okay? Understand? Now, given P1, P2, and Y, we may have our decisions on the consumption, on the optimal level of consumption on good 1 and good 2. So this is what we know. The endogenous variables Q1, Q2, and lambda are functions of exogenous variables P1, P2, and Y. So once you give me the exogenous level of variables as P1 equals 5, P2 equals 2, and income equals $300, I will tell you my optimal consumption on Q1 and Q2 would be 24 and 90. Okay? And if you tell me that, okay, now I'll give you one more dollar, make it 301. So our income becomes one more dollar. We got one more dollar on our income. It is now $300 and 1. So our solution would be 301 over 5 and 301 over 2 instead, right? It doesn't matter whether this is an integer or not. We do not require the quantity to be integers because it's about the unit, right? Oh, sorry. I did something wrong. It should be 2 over 5, 3 over 5. Should be this. Alright? So, the consumption on good 1 is a little bit higher than 24, right? And the consumption of good 2 is also a little bit higher than 90. Is that right? We now have a little bit more on Q1 and Q2. Since we have a little bit more on Q1 and Q2, our utility would be a little bit higher than before, right? In this case, we will have our utility, our optimal utility would be 24 to the power of 2 and 90 to the power of 3. Is that right? And now, our utility would be 24 point something to the power of 2 and 90 point something to the power of 3. Is that right? So do you think U prime is higher or U star is higher? Which one is higher? U prime, right? A bit higher than U star. Is that clear? So $1 more make us happier. An extra unit of the resource can bring us a higher utility, which is the marginal utility. Okay? So the difference between these two would be lambda. Lambda star. Okay? So lambda star measures the marginal utility caused by an additional unit of resource, which is income in this case. Is that clear? All right? Okay, now case number 2. Let's go back to the original one. And now case number 2. So let's make P2 from 2 to 3. So the price of good 2 is a bit higher than before. Okay? P2 rises from 2 to 3. So P2 goes up. And this is the result before the change. And let's find the result of after the change. Still, the power in the utility function is 2 to 3. So the expenditure will be the same because our total income is $300. So the expenditure on good 1 still $120, and the expenditure on good 2 is $180. So now our Q1 tilde and Q2 tilde. Q1 tilde will be 120 divided by 5 is 24 still. And Q2 tilde will be 180 over 3. It becomes 60 now. And the utility tilde would be 24 to the power of 2 and 60 to the power of 3. So you see the utility drops. The utility level drops, right? Due to the rise of the price. The increase of the price. Alright? So a higher price makes us less happy. And, alright, new partial P2, you see a negative sign here, a negative sign, which means the utility drops. So an increase in the price will make the utility drops. That's what the minus sign, the negative sign, represent or indicate. So totally, you will see, if we want to remain the same level of consumption, 24 and 90, the unit price is 5, the unit price now is 3. It would be 120 plus 270 equals 390. So actually we need $90 more to remain the consumption level. Okay? But it is impossible because we just have $300. So we cannot do this. But if you insist to consume 90 units of Q2, now the price is 3, so it will be 270. So since we cannot change our total income, if you want to insist to consume 90 units of Q2, which means you insist to remain the expenditure on good 2. So now you have only $3 left to consume good 1, is that right? So initially it's 120. Now you are left $30 only. The cut would be $90. Why it is 90? Because you consume 90 units of good 2, and for $1 higher the price of good 2, $1 higher, your expenditure will be, or your income will be cut by $90. Is that right? So you will see here, Q2 star, the quantity you consume, the optimal quantity you consume, is very important. The more the optimal level you consume, which means the impact of the price will be higher. So if you are a heavy lover, heavy consumer on some good, once the price goes up a little bit, you will be affected a lot. But if you are just a light lover, light consumer of something, actually you don't care too much on that thing. So even the price goes up a little bit, it doesn't matter to you too much. Okay? Say, if you are a Haagen-Dazs lover, you love Haagen-Dazs, you eat Haagen-Dazs per day, 1 cup per day. So if Haagen-Dazs gets more expensive by $1, and per month you will be affected by $30 or $31, right? Your income will cut by $30 or $31 because you have 1 cup per day. If you have 10 cups per day of Haagen-Dazs, oh, you're very rich, so that you can have 10 cups of Haagen-Dazs per day. All right, now, totally, it would be 300 cups per month. You consume Haagen-Dazs, you eat Haagen-Dazs, right? And now the price of Haagen-Dazs rises by $1. So per month, your income will be $300 less. You have to cut your consumption on other goods, right? And per dollar, lambda is the marginal utility per dollar. So if it is $300 in a unit, which means $300. You need to multiply by the utility per dollar, lambda. So it would be the total utility you lose by this effect, by the rise of the price. Okay? Is that clear? Okay. I didn't give you the derivation, the procedure like this, but you may still easily to have these two results by yourselves. Just follow the logic of this one. We may derive this from here, and it's a first order condition, which is 0. Another first order condition is a 0. First order condition is 0. So we have lambda star left. By the same logic, you may derive this to have the result. Not too difficult. Okay? So check by yourself. Okay, this is the last slide of chapter 3, and talking about the minimization problem. So we want to maximize our utility, we want to maximize our profits, we want to minimize our cost, and also we want to minimize our expenditure. So this is an issue, or is a problem of expenditure minimization. All right, here. We want to minimize P1Q1 plus P2Q2, which is the expenditure, right? The total expenditure. And we have a constraint. The utility function is constrained to some level, U bar. So the basic question, the basic issue, is here. Given this indifference curve, whose utility level is U bar, and we want to know what, and given the slope minus P1 over P2, the MRT of the budget constraints, we want to minimize the expenditure. Okay? So, in the previous slide, we are given a budget constraint, and we wanted to maximize our utility, right? Now we are, in this issue, in this slide, we are given an indifference curve whose level is U bar. We want to minimize our expenditure. We just reverse the problem, okay? So our objective function is the expenditure, we want to minimize it, given a constraint from the utility. Okay, let's take a break. It's 9:50 now. I'll see you on say 10:05. Okay, 15-minute break.